Welcome back. So in this video, we will go through a LeetCode problem, which is number of grid partitions. This is a hard difficulty level problem, and I found it a bit interesting, so thought of sharing it. So let's go over it. So you are given an array nums consisting of positive integers and an integer k, and we need to divide the array into two ordered groups, such that each element is in exactly one group. So partition the array into two subsets, and we want to they are asking us that a partition is called the great if the sum of the elements of each group is greater than equals to k, each subset sum is greater than equals to k, and we need to count the number of such great partitions, and the answer needs to be printed modulo 10 raised to 9 plus 7. And they're also mentioning that two partitions are considered distinct if some elements is in either one or the second one. Those orders are considered or counted different. So the obvious solution is to use dynamic programming here. Let's also go through some of the sample test cases that they have provided. So as you can see in this, we are given the array 1, 2, 3, 4 and k is 4. So below are the listed grid partitions of this array, and you can also note that the sum of both the groups is at least 4, and the answers for these cases are also given. As you can see, none of the element is greater than equals to 4 here, hence the number of partitions is 0. And for this case we have two different partitions, and as they have mentioned in the condition in the last statement, we are going to count them differently. So either the first element goes in the first group or the second one, and the count is different. And the constraints are also mentioned that array length is at most 1000 and k is also at most 1000. The values can be arbitrarily large up to a billion. Okay, let's go over some of the approaches. The obvious choice is to use dynamic programming, and with the following states, we are going to keep track of what is the index at up to which we have processed the array, what is the sum of the first group and the sum of the second group, and clearly there will be two choices at each index id, either to include it in the first group or the second group, and the recurrence can be found out using this relation. So this is a top-down approach. So if we start at some id, let's say id equals to 0 initially, and we are going from left to right, and we are also maintaining the sum of two groups as sum1 and sum2, then the first choice will be adding the current array element in sum1, and the second would be to add it in sum2. And the best case can be, as the question mentions, the group sums are at least k. So if we have found such a partition with sum1 and sum2 both greater than equals to k, then we can say that we have found one way, and this will be returned from the last index, which is id equals to n. And if this condition doesn't suffice, we are going to return 0, stating that this partition is not a valid one. And as I already mentioned, two choices at each state, either take the element in sum1 or sum2. The time complexity for this will be n times the maximum value that sum1 can take and multiplied by the maximum value that sum2 can take. And in this case, since the array elements are arbitrarily large, this value can be up to a billion. And we can also reduce this up to k, because since we only care about sum1 and sum2 being at least k, so if they exceed k, we can say that this condition is eventually going to be valid for any value of sum1 greater than equals to k or sum2 greater than equals to k. So this can be reduced to n times k square, but still it is not feasible for the constraints that are provided in the question. As we can see, n square k will be about 10 raised to 9 operations, and we need to make it faster. So let's go over another or optimized way to calculate these states. So we can notice that sum1 plus sum2 will be the sum of the array, because we are eventually going to consider all the elements in either sum1 or sum2. And since this is a constant, we can derive the sum2 from sum1. So the states can be reduced to only index and sum1 or sum2, depending on what you want to store in the state. And the recurrence turns out to be with the reduced state of sum2. So we only have two states now, and the recurrence turns out to be either to you add the element in the first sum or second sum. If you are not going to add it in the first sum, we are not considering it, and we are going to eventually considering it in the base case. So as we saw here, sum2 will be derived from sum1 using total minus sum1, and this case can be reduced. Again, the choices remain the same, and the time complexity becomes n times maximum value. And there is a caveat here. So you must be assuming that we reduced n times max square to n times n square in the first approach, but why can't we do it here? Why can't this simply be n times key? This is because sum1 is an increasing value as we go from left to right. So as we can see, the positive values are getting added here, and sum2 is constant. So sum2 is derived as total minus sum1, right? So this is the formula for sum2, and total is a constant and sum1 is increasing. So sum2 is in all a decreasing value. So since one state is increasing, other is decreasing, then we can't say that at any iteration or at the memoization point that if at some point sum1 is greater than equals to k and total minus sum1 is greater than equals to k, then at a later point or in the end also this condition will be valid. It may not be valid because the first state is an increasing value and second is an decreasing value, as we saw here. So the time complexity is n times max and not n times key. So this is still not up to the mark. So let's see what we can do further. So some of the observations are key is up to 1000. So we need to somehow adjust the states of someone to make the values, to store the values only up to 1000. And let's see how we can transform the problem into something like that. So as you can see, there can be only 4 types of subsets groups which can be derived. So first one is the first group has some less than k and second also has less than k, and so on for the 4 cases that I've mentioned here. And we want to find the groups of type 4. So the question demands the count of groups of type 4, and we know that the total number of subsets of any array is 2 raised to n, right? There can be 2 raised to n types of subsets, and considering one subset is considering a group partition, so we can simply denote it as 2 raised to n. And since these 4 types are going to consider every subset in a mutually exclusive manner, hence the count of subsets will be the count of the types of individual groups. And from this we want to find type 4 count, and type 4 count can be derived from 2 raised to n minus type 1 and type 2 and type 3 subtracted from them. And as you can see, 2 and 3 are equivalent because it demands that one of them is less than k and the other one is greater than equals to k. So 2 and 3 are equivalent, and we can substitute one of them with the other one to arrive at a formula which is the count of groups of type 4 will be 2 raised to n minus the type 1 and 2 times type 2. So this is the main idea which is going to help us to derive the solution. Now let's see how we can effectively count these. So effectively, to get to the answer, we need to know type 1 and type 2, right? So let's see how we can compute them. So to efficiently count the subset groups for type 1 and type 2, we are going to consider them individually. For that condition for type 1 is the first sum is less than k and second is also less than k. So we can simply use the second approach. The second approach makes sure that sum1 is the time complexity for the second approach was n times max, and max can be only up to k. So hence sum1 can be stored in this state and the time complexity will be of order n times k. This will be a valid solution for us. So now let's look at the case 2. In this case, we have sum1 is less than k and the second one is greater than equals to k. And as you already know, whenever the state is greater than equals to k, we can't simply memorize it or compute it in a better complexity than O of n times max, or it is a swapped condition. So what we can do is, since we already know sum1 and sum2 are related to each other, so we only need to store one state. And why don't we just store the first state? Because first state never exceeds k, so we only need to memorize values up to k, which is a valid reasoning for valid dynamic programming approach here. So what we can do in this approach is store the smaller sum in the state using approach 2. That makes sure that we only memorize values up to k for that state, and the time complexity in this case will be order n times k. This was the trick here, to only memorize the smaller value among the two. And this is how we are going to derive both of these values, type 1 and type 2 counts, for this formula, and substituting it, we are going to get the final answer. So once we compute the answers for both of these types in order n times k time complexity, both of them have equivalent time complexity, we are going to find out the final answer using this formula. So now let's go over the implementation. This is the C++ implementation for the solution. This is the same LeetCode type template for C++, so I will go through it. We have initialized global values for an instance of a class n and k, then total is the sum of the array itself, then the modulo value is provided in the question. Then I have used a dp table. Then this is the go1 function, which is going to count the groups of type 1, and go2 is going to count the groups of type 2. Before going them, I'm going to explain this part. This part is going to initialize the variables or parameters to the fields that are mentioned above, total, k, a, and n. Then the total number of subsets of array of size n will be 2 raised to n modulo the value, and this is simply calculating the power of 2 using while loop, multiplying 2, or this is simply a raised to b modulo mod, and this is a loop which goes through b times and computing the modulo. So total will store the value of 2 raised to n, and reset dp is to update the dp. Since I'm only using a single table for both of these recurrences, so I need to reset them before calling the other functions. Reset dp is simply going to update the values to -1, which is a unvisited state, and c1 and c2 are the counts of type 1 and type 2, as we saw here. So type 1 count will be c1 and type 2 count will be c2, and the respective functions for calculating them will be go1 and go2. And as we saw earlier, the count will be multiplied by 2 for type 2 because they were equivalent, and final answer will be total minus the subtracted counts for type 1 and type 2. Let's go through the recurrence function. So first one ensures that both of the groups have sum less than k. So if sum exceeds greater than sum exceeds k, we are going to return 0, saying that there is no valid grouping here. And the base condition is that the first group has sum less than k and the second one also has sum less than k. And we only need to memorize the smaller part, which never exceeds k. So this ensures that we are properly memorizing the solution, and time complexity is order nk. And simply this is going to resolve the recurrence that we saw earlier, which was this case. So this function is going to count the subsets, either don't take the current element in the first group or take it in the first group. And eventually we are going to mod the answer in each state and return it. Second type was to make sure the state that we are having here is less than k. The second one can be greater than equals to k, but we only need to check whether the first one is less than equals to k, because we are saying that the type 2, the first sum has value less than k, which is the parameter that we are storing in the recurrence function. And again, we are going to check whether to ensure that it never exceeds k, then the base condition is changed from this to this only by changing the value or the operator for checking the second sum being less than k in the first case and greater than equals to k in the second case, which we derived in this diagram. And the rest of the part remains same, the choices and finding the answer modulo mod. Yeah, this is it about the solution. Final answer will be written, and this is the C++ implementation for the same. I hope this video was useful. Yeah, thank you. See you again.